So you have different types of colloids based on the different state of dispersed phase and dispersing medium. As I just discussed with you, that dispersed phase are solute like components which are spread or dispersed throughout the dispersing medium, or solvent like components. So basically you have to study 8 types of colloids. These are the 8 types of colloids. Aerosols, 2 types of aerosols, then gel, emulsion, foam, 2 types of foam, then 2 types of sol, that is sol and solid sol. So we'll see one by one. Aerosol have dispersed phase, liquid or solid, in dispersing medium, gas. If aerosol are in the form of liquid gas colloid, that is liquid dispersed phase and gas dispersing medium, then the example of aerosol is fog, clouds, mist, etc. If the aerosol are in the form of solid gas colloid, that means solid dispersed phase dispersed in the gas dispersing medium or spread in the gas dispersing medium, then you have examples like smoke, exhaust from automobiles, etc. Then you have gel. You know the gel are in semi-solid, so it is actually made up of dispersed phase liquid which are spread or dispersed throughout the solid particles or in solid medium. Solid medium, yes. So semi-solid means liquid and solid dispersed phase and dispersing medium respectively, and the examples of gel are jelly, cheese, butter, etc. Then you have emulsion. Emulsion is a liquid colloid where liquid dispersed phase get dispersed in the liquid dispersing medium. An example for emulsions are milk, face cream, etc. Now you have foam. Foam are of 2 types. Here the gas dispersed phase are either dispersed in liquid dispersing medium or are spread or dispersed in solid dispersing medium. If the gas dispersed in liquid dispersing medium, then that type of foam are shaving cream, etc. And if the gas dispersed phase is dispersed in solid dispersing medium, then that type of foam is gas solid colloid, and examples are rubber, foam, sponge, pumice, etc. Then you have sol of 2 types. Here the solid dispersed medium, they get dispersed either in liquid dispersing medium or they get spread or dispersed in solid dispersing medium. If the sol have dispersed phase solid spread in the solid dispersing medium, then the type of solid liquid sol is are the examples are milk of magnesia, mud, paint, blood, ink, etc. If you have solid sol, that means solid dispersed phase are spread in solid dispersing medium, then you have examples for that solid sol are colored gemstone, milky glass, etc. So these are, once again I'll tell you, aerosol, 2 types of aerosol, gel, emulsion, 2 types of foam, then sol, solid sol, 2 types of sol. These are all the types of colloids based on different states of dispersed phase and dispersing medium dispersed together. Okay, so we saw today the different types of colloids and their examples. Students, so till now we discussed the properties of homogeneous and heterogeneous mixtures separately. Now in today's class we will study some of the physical methods and some special techniques which are used to separate the components of mixtures. So we have some simple methods like hand picking methods, sieving methods, then filtration method, sedimentation method and decantation method, and many more other methods which are called as the simple methods. Why they are simple? Because they are very simple to handle and we can do it just in our home, and there is no need of instrument or special apparatus for that. The first one is hand picking method, where we have to pick the undesirable material present in the mixture through our hand. So what are those undesirable materials? So undesirable materials may be the small stones, then pebbles or husk, or any other undesirable material which are present in the mixture of rice or in pulses or in wheat, etc. Now sieving is a process to separate fine particles from the bigger particles. Now filtration is a process to filter out or to separate the insoluble particles present in a liquid solution or a liquid mixture. Now sedimentation is a process in which settling down of heavier insoluble impurities takes place, and decantation is followed by the sedimentation process, where in decantation the sedimented liquid can be separated out by pouring it in other container very slowly without disturbing the settled sediment at the bottom of the container. So these are some of the simple methods that we usually apply to separate different components of mixtures. Now, as per your syllabus, you have to read some special techniques also to separate some of the components of mixture. So these all you have to study in this chapter. The first one is separation of dye from blue or black ink, and this can be done by evaporation method. Now second separation method is separation of cream from milk, and that is done by one special technique called centrifugation method. Now third is separation of two immiscible liquids. What do you mean by immiscible liquids? Immiscible is just opposite to the miscible. Immiscible means immiscible liquids are liquids which are completely insoluble with each other, and when you try to mix it by shaking, it will eventually separate out into two layers. For example, we can take oil and water mixture. So they are called immiscible liquids. So how can we separate those immiscible liquids? This can be separated by using a special apparatus which is called as separating funnel. Now next separation method is separation of a mixture of salt and ammonium chloride. You know that ammonium chloride, that is NH4Cl, is a sublime substance. So this can be separated out by a process called as sublimation process. Now next one is separation of different colored components present in a dye which are water soluble. You should know that dye is made up of mixture of different colored components in it. So how can we separate out those different colored components from dye which are all water soluble? So this can be done by one special technique called as chromatography. In chromatography, we have to read about the paper chromatography, because there are different types of chromatography. Here in this lesson, you have to study about the paper chromatography. Now, the next separation is separating mixtures of two miscible liquids. Here, we have to separate immiscible liquids. Here, we have to separate miscible liquids. Miscible liquids are those liquids which are completely soluble with each other. So if you have two liquid mixed with each other, soluble with each other, how can you separate it? You can separate it by the distillation process. Now the last separation is to obtain pure solid crystal from impure sample. So if you have got a solid sample which is not 99.9% pure, so you have to get the pure solid in the form of crystals. So how can you get that? So we can get the pure solid crystal from impure solid by the process of crystallization. So these are some of the separation techniques that you have to study in this chapter. So we will study one by one all the methods. Next is separation of dye or colored component from blue or black ink. So you should know what is a ink. Ink is a mixture of dye and water, where dye is a solute and water is a solvent. Dye is called colored component and it is non-volatile in nature, and water is a solvent which is volatile in nature. Now you should know what do you mean by volatile and non-volatile. So volatile substances are the substances which easily evaporate at normal temperatures. So we know that water evaporates easily, so we can say that water is a volatile substance. So ink is a mixture of volatile and non-volatile component, where water is a volatile component and colored component or dye is a non-volatile component. Hence we can separate it easily by the process of evaporation. So for that, we first take some of the ink droplets in a watch glass. Watch glass is a plate-like container. It is a small bowl or plate-like container which is made up of glass, and we take any chemical or any substance to watch it. That is why it is called as watch glass. So we will take some ink droplets in the watch glass, and we will keep it on the mouth of the beaker containing half filled with water, and we will start heating it. We need not heat it directly, so we will heat it by putting it on the mouth of the beaker. So when we start heating it, the water here in the beaker gets heating it. So whatever water is in the beaker, it will start heating, and indirectly whatever the component in the watch glass, it also gets heated. So what happens is, whatever the volatile or volatile substance present here, it will start evaporating slowly. That is water. You can see the water will convert itself into water vapor on heating, and we will watch it carefully till we'll see there is no change happening in the ink. So a condition comes when all the water present in the ink get evaporated completely. So at that time we have to switch off the Bunsen burner, and we will see it carefully and record our observation. So we will see that whatever the volatile component, that is water present in it, it got evaporated completely, leaving behind the colored component or dye in the watch glass. So that's how we can separate dye from water. That is, we can separate the different components of the mixture ink through the process of evaporation method. The next is separation of cream from milk. Now there are different types of milk available in market, that is full cream milk, toned milk and double toned milk. Full cream milk means it contains high amount of fat in it. Toned milk means it contains less amount of fat, and double toned milk means it still contains less amount of fat in it. So toned and double toned milk are generally used by those people who are maintaining their body weight. So we can separate cream from milk by using centrifugation process. So what is centrifugation process? It is a process of separating components of different densities from a mixture with the help of a centrifuge machine. I repeat, it is a process of separating components of different densities from a mixture with the help of a centrifuge machine. So what happens in centrifuge machine? Here the mixture is made to spin rapidly. So we can say that mixture is separated through spinning. So during spin, what happens? The denser particle, that is milk liquid, is forced to remain at the bottom, and the lighter particle, that is cream, stay at the top or float at the top when are spun rapidly. So there are different types of centrifugation machine available in the market. That is, for separating different components of blood, we use different centrifuge machine. For separating the butter from milk, we use different centrifuge machine. So there are various applications, as I told you before. The centrifugation process is used in diagnostic labs for blood and urine test. It is also used in dairies and home to separate butter from milk. Centrifugation process is used in washing machine to squeeze out water from wet clothes. There you can see the centrifugation process happening. There you can see the machine is made to spin rapidly. Now in earlier time also people used to do centrifugation process only by conventional method. So they used to do with the help of wooden milk churner. So what they used to do, people used to spin the wooden milk churner inside the vessel containing milk in it, and they used to spin the wooden milk churner rapidly, continuously, and for the long time. And after a long time you could see the spun like substance or float like substance floats on the surface of the milk, and that is nothing but the butter separated from the milk. So that's how they used to separate the butter component from milk component. Nowadays there are different sophisticated centrifuge machine are available in the market. So I have a video, you just have a look.
Conduct an experiment to see centrifugation. For this we need a handy centrifuge machine, muddy water, mixture of calcium carbonate in water, 4 centrifuge test tubes. Take the sample of muddy water and place the test tubes in the centrifuge machine.
These are a centrifuge tube.
Now take the calcium hydroxide mixture in the test tubes and also place them in the centrifuge machine.
These are the centrifuge tube. Hence we can separate out different components of different densities also from a mixture.
Rotate the machines fast for few minutes.
You can see machine is here, the test tubes are made to spin rapidly. This is a simple type of centrifuge machine.
Stop rotating. Remove the test tubes and observe. We see mud particles and white precipitate.
You can see at the bottom.
The test tubes.
Yes. The high density particle remained at the bottom.
This is the process of centrifugation. In a centrifuge, as we rotate, the substances experience centrifugal force away from the center, which forces the materials against the wall of the tube. The amount of centrifugal force experienced by any object depends on its mass and the speed of rotation. The components of a mixture get separated because the denser particles are forced to the bottom while the lighter ones stay at the top. So with an increase in the speed of rotation, even lighter materials can settle down. Centrifugation is used in diagnostic labs.
So we can use, so in different laboratories also, the RBC, WBC or platelets can be separated out from the blood plasma. So this was your second method we completed, separation of milk from cream. The third one is separation of two immiscible liquids with the use of separating funnel. Now next is separation of two immiscible liquids. As I told you, the immiscible liquids are those liquids which are completely insoluble with each other. Example we can take is the mixture of oil and water. It is an immiscible liquid. So this mixture, that is the mixture of oil and water, can be separated by the separating funnel. Now what is the principle behind this separation? So here it is when we'll mix the oil with water, we can see the two layers, two distinct layers of the mixture. One is of oil layer and one is of water layer. Since water is of high density, so it takes being heavier, it takes the lower layer. where the oil having the lower density than water, so it is lighter. So you can see oil floats on the surface of water. So here we have to take those immiscible liquid which are of different densities. That is, one liquid should have higher density and one liquid should have lower density, so that they forms the two distinct layer, and so that type of the oil mixture only we can separate it from the separating funnel. So you can see this is the separating funnel. This is the cork which you have to open and pour this solution in the separating funnel, and this is the stop cork. When you open this, the mixture will come out, okay, from the end of this separating funnel. This is the mouth of the separating funnel, and with one knob or with one cork we have closed this separating funnel. Now we have fixed this separating funnel with the help of one iron stand, and we have two beakers. Why we have taken two beakers? When we separate out water and oil, so it can be separated in two different beakers. Now what we have to do is we have to pour the whole mixture in this separating funnel. So when we'll pour the whole mixture in this separating funnel, we will again see the two distinct layer of water and kerosene oil. We have taken the mixture of kerosene oil and water. So we'll see that water takes the lower layer where the kerosene oil floats on the water. We will allow to settle it for some time so that all the water molecule takes the lower level and all the kerosene oil takes the upper layer of the mixture. Now we can see the two distinct layers, the two layers of oil and water clearly. What we will do, we will keep this one beaker below this separating funnel and we will open the cork. Now whatever water is there at the lower layer, it will come out and fill this beaker. When we'll see the water layer comes at the end till this level, we will again close the cork and we'll keep the second beaker below the separating funnel and we will again open the stop cork. Now we are remaining with only the oil layer, so all the oil will come out and fill the second beaker. So that's how we can separate the mixture of oil and water by using the separating funnel. Now I have a video, with that you will be more clear. I'll just show you one video now.
Let's do this activity with these materials. Let us try to separate kerosene oil from water using a separating funnel. Pour the mixture of kerosene oil and water in a separating funnel. Clamp the separating funnel on an iron stand and allow it to stand for some time. Open the stop cork of the separating funnel and pour out the lower layer of water carefully and collect the water in a beaker. Close the stop cork of the separating funnel.
You can see only oil
as
layer
the
is
oil
remaining.
reaches the stop cork and left behind in the separating flask.
Like that we can.
Now, let's discuss about the application of separating funnels.
So this is about the separating funnel. Now there are various applications of separating funnel. We can use separating funnel in different for separating different mixtures. Like we can separate mixture of oil and water, as we discussed now. We can also use in the extraction of iron from its ore, where the lighter slag is removed from the top by the method to leave the molten iron at the bottom in the furnace. So it is actually used in the extraction of iron. It has a great application in the extraction of iron.